Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. This episode explores the incredible journey of one of the most indestructible and valuable metals on the planet, gold. Created in outer space, an immense explosion blasted minute particles of gold at 70 million miles per hour into the rocks that form our planet. How tiny pieces of scattered gold accumulate to form massive deposits is one of Earth's great mysteries. To find the answer, geological detectives sift through ancient riverbeds, hunting for hidden treasures above and below ground, and investigating alien natural wonders, finding clues that will ultimately reveal how the Earth was made. Gold has mesmerized man for thousands of years. The oldest known precious metal, it plays a powerful role in almost every culture on Earth.
Since humans have been on this planet, gold has been prized. It is such a unique mineral. It is beautiful. You can take an ounce of gold and stretch it in a thin string, and it'll go for 35 miles.
But the key to gold's enduring value is its inactivity. It won't bind with anything else except itself.
Gold doesn't get used up, it gets recycled. The ring you're wearing may be the exact same gold that was in some of the gold the pharaohs wore centuries ago. With all these properties, it's no wonder gold has been treasured by man down through history.
Man has mined gold for thousands of years, but found only 160,000 tons worldwide, enough to fit comfortably inside a 4-bed house. Physicists discovered that this ultimate metal was created in outer space, long before planet Earth existed, over 5 billion years ago. Gold and other heavy metal atoms formed in the maelstrom of a supernova, a giant dying star. As it exploded, shock waves blasted minute gold particles across the universe at 70 million miles per hour, scattering them far and wide throughout the early solar system. As this cloud of rubble compacted together, the gold became trapped inside the rocks of the newly forming planet Earth. Widely dispersed and inactive, to this day, most of the Earth's gold remains as tiny, isolated particles in the rocks.
It's ironic, but gold is around us everywhere. It's in the soil in our backyards. It's in these rocks here in the riverbeds. But the problem is, it's in very small amounts. In these rocks, the gold may be at 1 part per billion. That's like finding just a grain of sand in an Olympic-sized swimming pool.
Unusually large stashes of gold are concentrated in a handful of very special places around the world. The largest in southern Australia, China, South Africa, Peru, and the western United States. It is the geologist's job to find out where and why the Earth accumulates gold in large enough quantities to mine. The first pioneers of gold geology were not scientists, but gold-hungry prospectors who scrutinized the rocks. Their story began over 150 years ago by accident. In 1848, in the small Californian town of Coloma, along the American River, James Marshall was digging a trench for a water wheel to power his lumber mill when he made an extraordinary discovery.
He was digging it down during the day and then using water at night to flush out the sand and gravel. And he looked, and there on the bedrock were a couple of gold nuggets.
Rumors of California's river gold spread like wildfire. By 1849, over 90,000 people from around the world descended on the state. Nicknamed the 49ers, these early investigators searched the streams in a bid to find their fortune. Their first challenge was to figure out where gold accumulates in the river, and they quickly discovered that gold wasn't just strewn anywhere along its course.
A clue to where the gold would be concentrated is black sand in areas like this. You take a sample and pan it out.
The 49ers soon learned if they found heavy black sand in their pan, they were on to a winner.
The process of panning is a simple one. You're really trying to separate light materials from heavy material.
In this sluggish water, the heavy particles sink to the bottom of the pan.
And you repeat the process of washing away light materials and then concentrating the heavies on the bottom until you get down to just the black sand and hopefully some nice gold. Even a small nugget like that.
In the same way, rivers and streams separate the heavy particles from the light. The gold and black sand are flushed downstream, but as they hit the sluggish water on the inner bends, they drop out of the flow. And it's here, in the sandbanks on the inside bends of the river, that the 49ers discovered an absolute fortune. In total, over 20 million ounces of river gold were discovered in the waterways of California. But when they investigated the valley sides, above the river, the 49ers discovered an even bigger stash of gold.
And they wondered, what was the deal with these gold deposits that were up and away from the water? They took a close look at them, and they could see that these boulders were round and smooth.
These rounded boulders are identical to those found in the rivers nearby.
And the reason is because it's an ancient riverbed. It's been left high and dry by the flow of the river. The river cuts downward and leaves these deposits behind. The miners continued to explore, and they found some just above the river like this, but they found others tens and even hundreds, even 1,000 feet above the modern stream.
Using powerful water jets, the 49ers blasted and flushed out a further 50 million ounces of ancient river gold from California's hills, which still bear the scars over 150 years later. Similar river gold deposits have formed all over the world, including the greatest treasure trove ever found, Witwatersrand in South Africa. Its discovery in 1886 caused another massive gold rush. But this river gold is not found on the surface. Miners must descend over 2 miles down the deepest mine shaft on Earth.
Half the gold on this planet has been produced from that one group of deposits. Most geologists believe that these unique deposits formed from ancient river systems, concentrating these in old river gravels.
Over millions of years, thousands of ancient rivers carrying gold spilled into a huge lake, dumping a massive gold deposit. This ancient lake bed is now buried miles underground. To date, Witwatersrand has produced over 1.4 billion ounces of gold, worth over $1.5 trillion. And geologists believe the same value of gold still remains untouched. In the search for California's river gold, 49ers found heavy black sand, a sign that gold is deposited on the inside bend of a river, and gold buried beneath rounded boulders in the valley walls, proof that rivers have been depositing gold for millions of years. The 49ers suspected that rivers were carrying gold down from a source somewhere in the mountain, the mother lode. But the quest to understand where this mother lode gold originated would take geologists deep inside the Earth and face to face with some of the most destructive powers on the planet. In the 19th century, the 49ers plucked 70 million ounces of river gold from California's streams and ancient riverbeds, valued at more than $80 billion. But this easy gold didn't last. The race was on to find the source of the river gold, the mother lode, and they set off into the mountains to investigate.
And this is what the old-timers were really looking for: a big wide vein of quartz filled with gold. It runs literally for miles through the countryside. They were able to mine millions of ounces of gold from sources just like this.
With the discovery of mother lode gold, prospecting changed from a solo quest to big business. Hundreds of mines sprung up all over California, employing thousands of men. Discovering what geological force had concentrated gold in California's mountains was a puzzle that would bamboozle scientists for decades. In 1853, the Allegheny mine opened in Sierra County, California. Today, it's over 3,300 feet deep, with over 40 miles of tunnels, all leading to one special slice of rock in the mountain.
Here I am in the middle of the mother lode vein. It must be about 40 feet thick, and it goes down half a mile into the earth. This is the gold-bearing quartz vein that the miners were seeking.
Quartz forms from a liquid, and as it solidifies, it somehow traps lumps of gold inside it.
It is loaded with gold. If we break these quartz veins open, though, we can see perhaps small amounts of gold within the quartz. This is just an amazing piece of quartz. You can see all the free gold in it. It's just bright and glistens. There are actually clues to how the gold got here within the quartz that was deposited with the gold.
Trapped inside the quartz are tiny bubbles of fluid. They are minute remnants of a stream of water and minerals that once gushed up this vein. Analysis of these fluid bubbles has revealed the extreme conditions that created the gold seam.
That gold was deposited at 600 degrees Fahrenheit. It was a very, very hot fluid that brought the gold and the quartz to this location and deposited the vein.
But it was a mystery. What was the driving force creating all this hot fluid which carried the gold? In an old quarry nearby lies a clue. The gold-bearing quartz vein, here stained brown, is flanked by strange beds of altered rock.
When the old-timers saw rocks like this, they would get excited. They knew they were getting close to the source of the gold. They would see these rocks had changed their color, and then they would get to the big mother lode quartz vein, the source of most of the gold ore. This quartz vein is sandwiched between these altered rocks. And looking at these altered rocks, you see they're all deformed. They're up on end, they're sheared up, they're broken, they're folded.
These veins run for hundreds of miles in a north. Similar sandwiches of gold quartz and broken rock are found along the entire length of California. And strangely, they all run parallel to the coast. Whatever immense force shattered these rocks must also have created the hot fluid which carried and concentrated the gold. But what was it? Geologists finally solved the mystery in the 1950s, when the revolutionary theory of plate tectonics shed light upon how California and its mountains were made. They discovered that beneath the Pacific Ocean, a giant plate of the Earth's crust moved eastwards. It plowed into the American continent, crumpling huge slabs of the seafloor as it went.
If this big rock is ancient North America, over the last 300 million years, we had a spreading ocean floor push the ocean and sediments on top of the ocean against North America and stacked these pieces of ocean floor and sediments on ocean floor up on end against Western North America.
California was pushed above the waves. A mountainous mass of crushed, crumpled, and upended rocks, separated by huge cracks running deep into the crust, creating a landscape compiled of giant slabs stacked parallel to the coast. This immense mountain-building process also had the power to create a piping hot fluid. Buried rocks were squashed under unbearable pressure. They superheated, and a 600-degree fluid was squeezed from them. Like water running in a river, this piping hot fluid had the ability to concentrate the scattered gold. As it washed through the rock, it leached out minute particles of gold, creating a mineral-rich soup. It poured into the giant cracks which pipelined it to the surface. As the fluid cooled, the gold coagulated and the quartz crystallized, forming a solid, gold-bearing quartz vein. In total, 35 million ounces of this mountain gold were blasted out of California, one of the most profitable gold mining areas of its time.
Wherever you have oceanic plates colliding with the edge of a continent, you're always going to create fluid, you're always going to move those trace amounts of gold, and that will get focused into major faults to form large load gold deposits. They're part of the mountain building process.
Similar gold-bearing quartz veins lie beneath the coastal mountains all around the Pacific Rim, where the ocean floor has crumpled under gigantic Earth forces. Scientists investigating how California's mountain gold formed have found ancient fluid bubbles, proof that a hot liquid deposited the quartz and gold. Parallel beds of broken, altered rock, evidence that the gold-rich fluid was squeezed from rocks as mountains formed. By the 1880s, only 30 years after the first gold strike, California's mountain gold became increasingly difficult to find. By then, gold hunters in neighboring Nevada had stumbled upon an entirely different type of gold deposit. But it was the sort of deposit that could drive men to murder. In the 19th century, 49ers found 70 million ounces of river gold. Then they began to ransack the mother lode, blasting out over 35 million ounces of mountain gold, squeezed from the rocks as California formed. For many years, scientists believed that only the colossal forces that created mountains had the power to concentrate gold scattered throughout the rocks. But gold strikes made in neighboring Nevada were to shatter this theory. Massive gold veins were found in the sagebrush hills of the desert. A tidal wave of gold hunters left California, heading east. The almost uncharted, desolate state of Nevada began to light up with life as gold strikes were made across the high desert. This was the gunslinging Wild West. And the rough mining town of Bodie had one of the toughest reputations.
It's hard to imagine more than 8,500 people up along this stretch here. Lawlessness, lots of fights breaking out. Lots of saloons, opium dens, and brothels.
It was said that a man a day was killed in Bodie. And some historians believe the fickle geology of these gold deposits may have played a part in this murder rate.
Here, the veins were much more segmented and broken up. So while one miner might be mining along on the vein, another miner might not be, which would lead to animosity and tension and the occasional fight.
Geologists realized that unlike California's gold seams, which ran parallel to the coast, Nevada's were scattered randomly across the desert. the hunt was on to understand why Nevada's gold veins were so chaotic. "300 miles northeast of the cramped old mine in Bodie is the Midas Mine. Large enough to drive a truck down, it's one of a handful of remaining gold quartz mines in Nevada, and it's a geologist's paradise.
It's wonderful to have an underground mine because when you go underground, you have a three-dimensional picture of the geology. It really helps you get a feel for what clues to be looking at that we might see on the surface, that we might see better expressed underground.
Working mines like Midas have become geological laboratories and are helping to unlock the mystery of Nevada's scattered gold veins. Every day, the miners drill the face and pack it with explosives, exposing new networks of quartz veins.
This is just like the old days, but more high-tech. They're gonna drill the face out, load it with explosives, and blow it up.
450 pounds of explosives are about to blow to reveal the gold-bearing quartz vein.
That was great, and to think it's so much safer than what the old-timers had to go through.
Once the dust settles, it's possible to take a closer look.
This is quite a nice big quartz vein. If I compare these quartz veins to the veins that I've seen in California, they're substantially different. For one, if I look at these bands, these dark gray bands in here,
These gray bands are the first sign that something very strange has happened here.
in a hand sample, I'll see that there's lots of gray material. All that gray material is silver. If I look even closer, I can see little fine flecks of yellow. That's gold. The source rock that formed all of these veins was much different than the source rock that caused the California veins to form. The California veins only have gold, and these are loaded with silver.
And the clue to the identity of the source of Nevada's gold lies either side of the quartz vein. Unlike California, these wall rocks are not crushed and have never been on the ocean floor.
This wall rock is of a volcanic origin, very similar to like Mount St. Helens.
So it wasn't mountain building that concentrated the gold and silver in this vein, it was a volcanic process. Perhaps the Midas Mine was once a giant volcano. Geologists went looking for clues not inside the mine, but directly above it.
Everywhere above the Midas Mine, we see these strange outcrops. They're flat on the top like a table, and if I look closer, I can see fine little bands and layers.
The outcrop is made of thin layers less than 1/8 of an inch thick. And there are thousands stacked on top of each other like a deck of cards.
You've got browns and yellows, whites and purples. Understanding outcrops like this will help us understand why gold is deposited at such shallow depths within the Midas Mine.
These distinctive layered rocks are not formed by a volcano, but another type of volcanic process that can still be seen today. In Gerlach, northwest Nevada. In the middle of the dry, black rock desert, they found a mysterious oasis. And rising out of the landscape, a spectacular, multicolored hot spring, one of over 300 in Nevada. This bizarre geological wonder began to form just 45 years ago. Volcanic processes beneath the earth heat the groundwater. It spills out at the surface, and like a boiling tea kettle, dumps a layer of mineral scale.
The water is slowly running over the tops of these terraces. It's depositing minerals in fine little sheets, kind of like a deck of cards or a book on end. This rock from over there has fine laminations or layers. Rocks like these and terraces like those are found right above the Midas Mine, which tells me that Midas was once an enormous hot spring.
Geologists realized it was hot springs that brought the gold and silver quartz veins to the surface in Nevada. Gold and silver particles are scattered in molten rocks deep inside the earth. This hot rock released a gold and silver-rich fluid. As rainwater soaked into the ground, it reached the scorching rocks deep in the crust and superheated to 900 degrees Fahrenheit. Hot and buoyant, the water began to rise, sucking up the gold and silver soup as it went. As it neared the surface, the water boiled and dumped bands of silver and flecks of gold in the chaotic, fractured pipework of the hot spring.
Imagine this landscape 15 million years ago. Volcanoes as far as the eye could see, hot springs dotting the landscape here and there.
Gold is forming at this moment in hot springs all over the world. Even Yellowstone has traces of gold in its water. One of the world's biggest and most profitable gold mines, Yanacocha, northern Peru, is a gold and silver deposit which man has plundered since the rule of the Inca 800 years ago. High in the volcanic Andes, it's a massive 535 square miles and has produced over $5 billion worth of gold, all of it originating beneath a bubbling hot spring. Scientists investigating how gold-silver veins formed in Nevada have found volcanic wall rock, proof that the gold-rich fluid came from molten rock, and a multicolored layered outcrop, evidence that ancient hot springs deposited gold in Nevada. Nevada's hot spring gold deposits yielded over 40 million ounces of gold and 500 million ounces of silver. But by 1920, Nevada's gold seams were increasingly uneconomical to mine. The desert became littered with ghost towns. It looked like America had run out of gold. But in 1961, a new type of deposit was found. But it couldn't be seen or touched. It was invisible. It would become the biggest strike in the history of America's gold. America's gold was concentrated by incredible mountain-building forces that formed California and volcanic processes deep beneath Nevada's hot springs. But as the deposits became exhausted, geologists frantically searched for new stashes of gold. Then, in 1961, geologist and gold prospector John Livermore noticed a suspicious 50-mile-long crack in the middle of Nevada called the Carlin Trend and set out to investigate.
John Livermore came to these hills following up a theory that gold deposits would be aligned directly above a deep crack in the Earth's crust. He'd come up to outcrops like this, and he would go ahead and want to look at them.
The rocks are a strange mixture of mud and quartz, a mineral created in hot fluid, and a good clue that gold might be deposited nearby.
But based on his experience, he knew a lot of hot fluid had come up this crack. However, he couldn't see any evidence of gold, no quartz veins, no visible gold. But on a hunch, he sampled this rock, took it back to the assay lab to see if there was any gold in it.
In assay labs, rocks are crushed and blasted in a furnace to over 1,800 degrees. And as the liquid rock cools, the minerals begin to separate.
At the end of this process, something extraordinary has happened. An ordinary-looking rock actually contained a grain of gold. At a concentration of about 5,000 times you would normally see in the Earth. It doesn't look like much, but this is what they mine every day.
Livermore's hunch paid off. 50 miles long and 5 miles wide, the Carlin Trend is now one of the largest mining districts in the world. This vast man-made pit is big enough to be seen from space.
This is the Betsy Post Pit, one of the world's largest gold mines. It contains 45 million ounces of gold. They have to mine 10 tons of rock in order to get 1 ounce out. As you can see, it's huge, 2 miles long, a mile wide, 2,000 feet deep.
Because gold is so valuable, the extraction of just a few thousand ounces a day pays for this extraordinary mining operation. And removing the gold ore requires drastic action.
Wow. That's what 400,000 pounds of explosives looks like.
Giant diggers work 24 hours a day, excavating over 90 million tons of rock a year, enough to cover Central Park in 55 feet of rubble. But within this raw gold ore, not a speck of gold has ever been seen with the naked eye.
The mystery is, where's the gold? You can't see it. The rocks look really ordinary. The clue to where this gold is hidden is in the internal structure of this rock.
Magnified 500 times, the gold is still invisible. But this rock is an extraordinary lattice of quartz and mud, perforated with strange cavities.
It looks like a honeycomb, like something's eaten away at it. Clearly, some strange geologic process has concentrated and hidden the gold in the rock.
Scientists realized if they were going to solve the puzzle of how gold came to be hiding in these rocks, first they would have to understand where the rocks came from. A clue was found in the 19th century by cattle rancher Absalom Lehman in the eastern reaches of Nevada.
In 1885, Absalom Lehman stumbled upon a hole in the ground, and with rope and lantern, he lowered himself in the earth and discovered this beautiful cave system with some of the most spectacular cave formations in the world.
The solid foundations of this cave are made of a messy mixture of mud and calcium carbonate shells. They are the remains of tiny sea creatures, evidence that Nevada was once covered by an ancient tropical sea.
For millions and millions of years, creatures with shells composed of calcium carbonate began to rain down through the ocean and accumulate on the seafloor, forming this calcareous ooze. Later, this ooze hardened into a sedimentary rock called limestone.
They were formed when water eroded the huge limestone bed that sits underneath Nevada. And back over at the Carlin Trend, scientists noticed that the gold ore was made of a very similar type of rock. They figured out that the Lehman Cave limestone and Carlin Trend gold ore must once have been the same rock.
This is fresh limestone. This is gold ore. Clearly something happened to change this rock into this spongy gold-bearing ore. Well, the clue is in the chemical reactivity of this limestone. If I put dilute hydrochloric acid on this limestone, note how it fizzes. Very reactive. The acid is eating away at the rock. Now if I put the acid on the spongy gold ore, no reaction. The fluid is soaking into the rock like a sponge.
Scientists concluded the reason Carlin Trend gold ore did not fizz is that it had already been attacked by an acid. Beneath the bed of limestone at Carlin is a gigantic vertical crack. Geologists now believe that a blast of hot, acidic, gold-rich fluid was once forced upwards from deep within the earth. It streamed through the crack, drenching the limestone. The acid ate into it, leaving a sponge-like, muddy framework behind. And in the cavities, it dumped quartz and the most minute sprinklings of gold.
It's only been very recently that scientists have been able to use even more sophisticated imaging equipment, microscopy, to image down to the scale of individual atoms.
Magnified 100,000 times. Tiny specks of sub-microscopic gold can be seen embedded in the rock. Zooming in further, a staggering 4 million times, the gold particle is finally revealed. This fleck of gold is only 5 nanometers in diameter, 1/1,000,000th the size of a pinhead, and each tiny white dot is an individual gold atom.
These ordinary-looking rocks have produced 65 million ounces of gold from a single crack in the earth known as the Carlin Trend. And it's made the United States the 4th largest gold producer in the world.
Scientists investigating how Nevada's gold ore formed have found a sponge-like rock structure, suggesting that something ate away at the limestone. And gold ore not reacting with acid, evidence that an acidic fluid had already attacked the limestone, showering it with minute particles of gold. Similar Carlin-type deposits have since been discovered, yielding a further 35 million ounces of gold. Yet these discoveries may only be the tip of the iceberg. Geologists are now using state-of-the-art equipment, hoping to unlock millions of ounces of American gold trapped deep beneath the Nevada desert. Throughout world history, over 5 billion ounces of gold have been recovered by man. And almost 1/10 of this has been found in California and Nevada, adding up to a staggering $280 billion worth of bounty.
How much remains is anyone's guess. There is no reason not to assume as much gold exists as has been mined in the past. But geologists, prospectors, explorationists have found the easy gold.
In the past, prospectors and geologists homed in on this easy gold by following geological clues exposed on the surface. But vast areas of Nevada are covered in a deep layer of mud and gravel that has been eroded from the surrounding mountains. Geologists believe hordes of gold still lie concealed beneath this layer of gravel, unseen by anyone for millions of years. Finding all this buried gold in an area covering 110,000 square miles is no easy task. But one man has the ability to see under the ground using pioneering technology.
I've got gold in the hills around me. I've got good reason to believe there's gold beneath me in the rocks if I could just see through this sand and gravel. This little piece of equipment, I believe, is going to help me figure that out.
The geoprobe is drilling not for rocks, but for groundwater 200 feet below the surface. And it's this groundwater that holds the key to finding Nevada's hidden gold.
If there's a gold deposit concealed by the sand and gravel, the groundwater will interact with it and it'll pick up clues.
Traces of metals associated with gold seep into the groundwater, clues that will lead Hodges to the secret location of the gold deposit deep below the surface.
Imagine an iron bar rusting in a bucket of water. The trace metals are going to come out of that rusted iron bar, are going to be disseminated in the groundwater, and you would be able to sample that groundwater and tell that there was an iron bar somewhere nearby. Just as we're going to be able to sample this groundwater and know that there's a gold deposit somewhere nearby. So in a sense, it's like the deposit of gold is creating a scent.
If Hodges can latch on to a whiff of this scent, he can track it back to find the gold. Once the drill is deep enough, Hodges pumps out the groundwater.
Okay, I think I've got enough sample now. Somewhere in this bucket of muddy water, I believe you've got some clues.
This is no ordinary pickup truck. It's a state-of-the-art mobile laboratory. Hodges measures how many trace metals are in the groundwater, and the scent here is particularly strong.
And it's telling me that I've likely got a lot more trace metals: arsenic, antimony, mercury, copper, lead, zinc are the kinds of trace metals that are often associated with gold deposits. And it looks to me like we've moving in the right direction.
In the same way the old-timers traced the gold up into the mountains, Hodges tracks the increasing concentration of trace metals in the groundwater.
It's like a little childhood game of hide and go seek. Am I getting hotter or am I getting colder? And that makes it a science.
The net is tightening around the gold deposit. The scent is strongest in this 4 square mile target zone. But it's still too large an area to begin test drilling for gold. To focus in further, Hodges needs to literally see inside the earth.
Well, this instrument here is a gravitometer. And it has the ability to measure how dense the rocks are beneath this point. Just as there's a landscape here on the horizon behind me, there's a landscape in the bedrock underneath me.
Multiple readings from the gravitometer create a secret treasure map of the terrain submerged beneath the surface gravel. From this rock density map, Hodges can pinpoint the likely location of the gold deposit. He has found a suspect gash in the earth over a mile long and 250 feet below the surface. It's a good sign, as gold is often found deposited in deep cracks. It's time to start drilling for gold. The diamond-studded drill probes the crack and extracts a cylinder of bedrock. This is the first in a sequence of test drills along the crack, and the results are tantalizing.
After all this traveling around, I'm finally able to see the rocks for the first time. These rocks have been out of view for millions of years, and to me, it's one of the most exciting things about this line of work. I get to look at these rocks before anybody else has ever seen them, and I can compare them with the rocks that I've seen elsewhere in the mountains. In this piece of core, I've seen several different kinds of fragments of rocks. Some of them are quartz. Quartz, we know, is good for gold.
Hodges could be on the verge of a massive gold strike, adding to his tally of 30 million ounces discovered so far.
Reaching down into the earth, pulling out a sample that says there's gold in it, and realizing that you've done it. And in a sense, it connects you with those old timers, the same spirit of the Old West. It's exciting.
It's pioneering geologists like Hodges who will find what's left of America's gold. Scientists and prospectors investigating how gold is concentrated around the world have found gold in heavy black sands, evidence that rivers concentrate gold on the inside bends. Parallel beds of broken, altered rock, proof that gold-rich fluid was squeezed from California's mountains. Multicolored, layered outcrops show that ancient hot springs deposited gold quartz veins in Nevada. And spongy gold ore, evidence that an acid dumped minute sprinklings of gold in the rock. The Earth does not relinquish her gold treasure easily. Man's irresistible urge to find gold is the driving force which helped pioneer the science of geology. Investigating how gold is concentrated across the world is not just a story of metal and mining. It's an epic tale that has revealed how the Earth is dynamically changing to this day, and over billions of years of the planet's history, living proof that the Earth is never at rest.